First, we're going to get the equation into y equals a times x minus h parentheses squared plus k form. But instead of h, we're going to use the variable t. And we're going to use the alternative way for getting the proper form of a quadratic function. It's different than completing the square. Okay, so here's how it works. We're working with y equals negative 16t squared plus 256. And we're comparing that to y equals a times t squared plus b times t plus c. And making that comparison, we can see the a value is equal to negative 16. The b value is equal to just 0. And the c value is equal to 256. Now I want to note that since the a value here is the same as it's going to be when we get it in the standard form, that negative tells us that we're going to have a sad face parabola. Okay? Just for reference, that means that the actual vertex v is going to be a max point. It's a max point. All right, so let's continue with the process. We know the a value. Now we need to get the h. The h value comes from a formula, negative b divided by 2 times a. So let's plug our values in there to calculate h. H is equal to negative 0 over 2 times negative 16. But 0 over any non-zero number is just 0. So h is equal to 0. Okay, now let's find k. K is the original function f, well, I should say h in this case. It's f of h, right? So in this case, what's analogous right here to f of t is what we're looking for. I mean, we're using y equals f of t. So that tells us that k is equal to this function, negative 16 parentheses squared plus 256, where we replace t with this value, 0. So k is equal to 0 plus 256, which is equal to 256. So k is equal to 256. Okay, so we've got our hk, and that tells us, together, that tells us that the vertex v equals hk is equal to 0, 256. Okay, so we're trying to answer part A, what is the maximum height reached? And that would imply, let's go to part A. The result that we have here shows us that for this particular problem, where we know A is negative, so the actual parabola is upside down, it's a sad face parabola, that tells us that the vertex, let's draw it again, the vertex, which is hk equals 0, 256, is a max. And since the x-coordinate represents height, the x-coordinate in this example represents time, and the h of t, which is the y-coordinate, represents the height, that means that the y-coordinate is the height, and the t-coordinate is the time. Okay, so since we have an upside down parabola, the vertex is a high point. That means the y-coordinate, which is 256 feet, is max height. Part B, when does it hit the ground? Well, it hits the ground when the height, h of t, is equal to 0, obviously. So that implies it hits the ground when the y-coordinate is equal to 0. And that implies that it hits the ground when we have the x-intercept. A, comma, 0. So we're going to find this intercept by, first of all, taking the h and k that we just found and forming the, well, we can actually use the equation that we originally had. Our original equation was h of t equals negative 16t squared plus 256. And we're going to let the height equal 0. Okay, let's move the 16t squared over to this side. Divide both sides by 16. 16 times 16 is 256. Now we take plus or minus the square root, but time is only positive, so we'll take this positive square root, and that equals 4 seconds. That is the time after it's launched that it will hit the ground.